Here we have an example of a piano wire with mass 3 grams and length 80 centimeters stretched with a tension of 25 newtons. A wave with frequency 120 Hz and amplitude 1.6 mm travels along the wire. Calculate the average power carried by the wave. What happens to the average power if the wave amplitude is halved? First we determine the given values based on the problem. We have the mass of the piano wire, the length of the wire, the tension of the wire, the frequency of the wave, and the amplitude. To calculate the average power carried by the wave, we use equation 1 for power, but we determine first the unknown parameters. We determine the linear density using equation 2 and the given values. The angular speed by using equation 3 and use the given frequency. And the speed of the wave using equation 4 and the solved linear density and the tension in the wire. We then substitute the solved values obtained using equation 2, 3, and 4 to equation 1 to solve for the power. We get that the power is about 0.2 watts. This is the average power carried by the wave on the piano string. To determine what happens to the average power if the wave amplitude is halved, we use equation 1. We write an expression for a new power where its amplitude is halved as shown in equation 5. We simplify this equation and we get that it is simply a quarter of the previous power. Substituting the power value obtained in a where the power is not yet halved, we get that the average power if the wave amplitude is halved is about 0.5 watts.